Yesterday I posted a tweet. In the tweet I was showing some very specific behavior of the Scala compiler, which was able to parse, compile, and run a git conflict marker as Scala code. It was of course embedded in some other Scala code, but it worked nonetheless. So in this video I'm going to look into why this worked, whether it should have worked, and I'm going to explain all the mechanisms that are making this possible. And then finally, I'm going to rate this feature or bug on a rate of blessed to cursed. So this is F around and find out episode 2. Let's get to it. So we have this, we have a print line with a hello. Let's make a new branch. What we need to do is cause a git conflict. So I'm going to make a new branch. Let's call it just git1, something like that. Okay, git1 already exists, let's call it git0. And I'm going to change the string to world. So instead of hello, we'll have world. Let me commit that. And I'm going to get back to the previous branch. We're at hello again. And I'm going to add an exclamation mark. Just anything that will break this line, cause a git conflict. So exclaim. So now we have that on the main branch. And now we can try to merge the other branch, the git0 branch. And that is a git conflict. So let's try to run this code. I'm going to try to run it with Scala CLI. And I'm going to use Scala 2.13 just to use a specific Scala version. But yeah, what happened? It didn't quite run or compile, but these errors are not like syntax errors. They are just errors from the compiler saying this value doesn't exist or that value doesn't exist. And we can actually get this to compile because it parsed. It parsed because we get very semantic information, something that seems like it understood that this is Scala code. But first, let's look at what the actual code looks like without the VS Code magic. So this is it. We have this marker here, the name of the reference, git reference that we were trying to merge, number 1, some code, then another marker, another string, which is the new value from the other branch, another marker, and then the name of the branch that we're trying to merge into ours. In theory, if we make all of these things, like these less than signs, head, the equal signs, the greater than signs, and git0, if we make all of these valid Scala symbols, it might actually get to compile and run. So yeah, let's try to run it again. It doesn't work, of course. Let's try to make it work. Now I have formatting off, but if you run a formatter on this code, you'll get something like this. So that sort of starts to look like Scala code. So let's try to make this run, or compile at least. So yeah, we need this symbol, right? This 7 less than signs. I'm going to make it an object so that it's just a value. And yeah, I just happen to know that head needs to be a method. Let's take like an int. Let's call it I, and just return another int. I'm going to not implement this for now. Let's try to run it again. Now it complains because the other symbols are not there, and these equal signs are supposed to be a member of string. And there's one way to do it in Scala that works across all Scala versions, modern Scala versions, that's using an implicit class. So string get ops. I'm going to make it an implicit class, and I'm going to call this method exactly what they want me to call it. And again, it's going to take an int and return an int. And now it complains that the greater than signs are not a member of string, so we do the same thing. Let's just rename this and compile. And now we just need git0. I'm going to define it right here. And it's compiled. It actually compiled and it runs. We can even make it, run without failure, something like just return I, and just return I, and this runs. So how did this happen? Well, we need to dive into a couple of Scala features. First of all, we have these implicit classes. These are used commonly for extension methods. Basically, you add methods to this type here, to the string type, by declaring an implicit class. In Scala 3, there's new syntax for this. You can just say extension string, something like this, I believe, is the syntax. Actually, we can try that way. Let's just use Scala 3.2. Sorry, 3.2, not 4.2. And yeah, that is the syntax. But I want this to work on Scala 2.13, so let's get back to this. So that's feature number one, but then there's also the feature that allows custom operators, right? So in general, when you have something like this in Scala, a plus b times c is greater than d. When you see something like this, these names are not like special Scala embedded features. They have some rules as to which one gets picked up first. Depending on these rules, something will be picked up first, maybe this way, maybe that way. These virtual parentheses will be inserted. You can think of it that way. But yeah, you can define custom operators using this or using plain methods on the types that you own, and then they have to obey to these rules so that you can apply them with white space. Normally, when you have something like a plus b, just to simplify, let's use the same operator. This would be desugared, like this is syntactic sugar, which would be desugared into something like a dot plus, b as a parameter, dot plus, c as a parameter. With multiple like different operators, this will get a little more confusing because a plus b plus times c, multiplication binds first, right? So we definitely need something like that. And this would be changed into something like this. So the function call to the multiplication operator is nested in the parameter of the plus. And something very similar happens here with these conflict markers. So let's try to rewrite what we got here as a raw piece of syntax. Let's try to rewrite this into the form that is like fully expanded. That should explain how this feature or how this whole thing came to work. So this is what we have, and just notice that if I indent this, dedent this enough, it shows up as a conflict in VS Code. But normally, yeah, this is what I copy pasted. And yeah, let's try to make this work the right way, like the same way as the above, except without the whitespace syntax. So we'll just call functions. So head is definitely a function. Now, the question is whether this operator binds before that one. And for this, we need to consult the Scala manual. I don't remember this by heart, neither should you. So here are the rules. First, we have characters not shown below. So any special characters that are not included in this, they are not letters or any of these two operators, they would be bound first. Then we have multiplication, division, and the remainder operator. Of course, you can redefine these operators for your types using, they can do anything you want. It's just what I call them, the asterisks, I guess, the slash and the percentage. And then we have plus, minus, colon. And this is based on the first character of the operator name. Then we have less than, greater than, and equals. Equals was last, and greater than was before that. So this will have to be bound first in this whole sequence. And then it should be pretty simple. Like here we have no choice, there's going to be a dot, and the whole thing is going to be a parameter. So now I can format this maybe. Let me just fix this conflict again. This is supposed to be just like that. But yeah, this is now fully formatted and it's going to be the same thing. Let me just remove all the white space. Also, yeah, the Scala FMT formatting actually removed the spaces, sorry, the dots, but I want them. I want this to look like function calls. And yeah, this is what it's supposed to look like. Now let's just prove that this is exactly what Scala does. We can look at the desugared code from the compiler. So for this, I'm going to use plain Scala C. And normally you can compile a Scala file like that. If it has no dependencies, that's just going to work. Scala C, I think, is version 2.13.10. So I'm going to run this with the xprint parser flag. This will show me the syntax after the parsing phase. And the parsing phase is the one responsible for the syntactic sugar and expansion of it. And we're supposed to have two print lines, right? The first one that is the actual git conflict, and the second one that we just made up. And they are supposed to be the same after desugaring. And this is the first one. Below is the second one. Let's just make sure they're the same. Let me copy this. Very primitive way, but it seems like they are indeed the same. So this is what it would get desugared to. And yeah, all these names, like the less than, that would be desugared to $less. We might even be able to call it this way. I wouldn't do it, but apparently it works. So yeah, that's an interesting piece of trivia. So yeah, you can call it this way. Maybe you can even mix and match. That would be very cursed. Okay, you cannot do that, I think. That's actually good. So let's get back to this. And yeah, hopefully this explains why that worked before formatting, why I was able to format this code as well and compile and run it. Now, here's my rating, like, is this feature good or not? So operators in general, I think that deserves a blessed verdict. So that is absolutely a good feature, and sometimes using symbols instead of full-blown names, it can make your code base nicer to look at. If you use a limited amount of these operators and they're well known in your code base, I think that's okay. Like nobody's going to complain about this if they are spending some time in your project. A common example of such an operator would be the right shark. People using cats probably know this very well. And yeah, it's probably one of the most liked operators that don't come from the standard library. So now you can actually understand what order it binds in, like it goes as one of the first operators, right? That's good to know. But maybe if you were to define operators like this, that would actually make it kind of cursed. So I declare this feature, like the fact that you can parse a git conflict, as hella cursed. Like, don't do this ever. Don't rely on this. Don't build libraries that define these exact sequences of symbols. Okay? Like, if you do this, you are exiled from the Scala community forever. But what I hope we can learn from this, and what I hope we can get in the future, is the compiler giving us something like a warning, maybe. If the compiler is able to parse this code and see these exact symbols right next to each other, maybe it could tell us, like, hey, you have an unresolved git conflict. I can parse that, but I shouldn't be able to. Maybe something like that could happen. Again, this is the feature. I think it's, yeah, as I said, it's hella cursed. But the whole thing about Scala operators being just methods and special syntactic rules, it's relatively simple to understand once you know the basic Scala syntax. And then this is probably the most complicated part about it, like the fact that you need to maybe not memorize, but be aware of this precedence table. So yeah, just keep it in mind that it exists and make sure that you can access it whenever you need to. And maybe don't mix too many operators together. Usually it would be best to use parentheses. For example, let's say even something like a plus b times c. Most people know that multiplication comes first, but maybe you can do this just for your code base's sake, just to make it a little more readable. Okay? When you mix different operators and use the same one, it should bind from the left to the right. That's what I forgot to say. But yeah, this should be, like, that's probably redundant. But, you know, do whatever you think is right. With that, let's end the video. Please don't tell anyone about this cursed feature. Don't like this video, don't subscribe, and I'll see you in the next episode.